Hi, in this session I'm going to give you a short introduction to R. The content of this section R is talking about R itself, data structure, creating objects and assigning values, indexing, R packages, how you deal with error and warning messages, and further reading and learning. In this section, it's a bit of a show and tell. So I will talk about some aspects on the R using these slides, but also I'm going to go to the R itself, showing how the code works. In order to do this, I'm going to do a bit back here, and I will go to the main page of our course, and I'm going to download the classroom materials. So this classroom material is basically a zip file with the project data inside. So remember from the previous section on project-oriented workflow, when I talked about the data structures and how the folder should be organized. So here we can find one example for this course. So I click here, and it leads me to the GitHub webpage of our course, and then I just need to download it. And now I have this folder. My system already downloaded as a regular folder. I didn't need to unzip. But generally, if you download from other softwares or other navigators like Chrome, you're going to get a zip file, and then you need to unzip, and you're going to get this folder with this structure called the tricot-analysis, and it has this structure. Now the data, as I said, is where all the data is stored. Now, so in that case, we have one folder called sweet potato and the other one called common beans clean.rda. See, the RDA files are basically the R data, so it's a kind of file that's native to R. And here we have the scripts with all the sections that needs some kind of script, and also the exercise for each of these sections. So we propose 6 exercises for you. And here, this is the folder called tricot-analysis, which I said in the project-oriented workflow, which is like the door for your kitchen. Now, if you want to cook, bake a cake, so you don't need to go from the window or from the ceiling. You just go through the door, which is this case is the tricot-analysis folder art project extension. So to make it a bit more clear, I will take this folder and will copy it, and I will put it in the folder that I have all my R code. So this is all the folder that I have all my R code, and I will just copy it here, and I have this folder called tricot-analysis. I open it, and then I will open the R project. So here we have the R project with the RStudio environment, and I'm going to show you some things of this in the next section. But let's go back to R again. We put this like this, and we go back to R. So what is R? R is a free open source programming language and software environment for statistical computing and graphics. So you can make analysis and you can do computing, and also you can produce graphics, like charts and all images that are needed for depending on the analysis that you use. So for example, you can use raster images, you can work with shape files, and you can do geographic information analysis. There is a lot of things that you can do with R. And for example, currently there are people doing machine learning and other more deep learning studies using R as well. So it's a software for data science, so you can do experiments and survey design. You can do data retrieval, which is what we are going to do with the picking the CleanUp data from the CleanUp platform to R. Data wrangling, which is basically moving around the data to different formats and the way that it's useful for the analysis, which is something that we are going to do when we transform the tricot rankings into the Placket Plus rankings. Data analysis and reporting. And also is a programming language, so we can use existing functions to wrap code. You know, if it's very useful. If you have some code that you think that is useful for others, you can just make it as a function and you can share with others. So it's also a way to increase the number of code in the environment. So you can download R in this link. So this is the main web page of the R group. No, it's the R project, and there is the option to download it from R for Linux. There is R for Mac and also R for Windows. So if you don't have downloaded it yet, please download it and be sure that you are using the latest version. So in that case, for example, today the latest version is R.404. So the R code along is basically it's very similar to any other computing languages. Is you can just put the data and write some code, and it's basically like this. For example, if you want to know what is the 3 plus 4, you just need to type it, and then it will return to you the answer for it. You can also, for example, compute a logarithm. You can also check, for example, take data from other places, and then you can also plot it now if you want to plot the data. And this is the RStudio, the environment that I was showing the minutes ago. And basically is RStudio has 4 panels. The first one is where you write the code. So this is basically this is an R script file when you can write the code that you're going to use. So going back to the analogy on the baking a cake, it's here that you write the recipe for the cake. Here you can see the environment is the place that you can see all the objects or all the things that you have created so far. So in that case, in going back to the analogy, here is where you see the ingredients for the cake, you know, all the things that have been done so far. So if you mixed the eggs with the flour and created something that's not egg, not flour, it's a mixture, and then here is your place where you can find it. And this is the code that you can when you run the code. Now you see that we call it console. So here you can run the code, but be careful. If you write code here, you're not going to save the code here. The code is going to be lost unless you go to the history of your code here. So this is just for you to check the outputs of your results, now the console. I recommend you to write the code here in this place. And here is where you find the files and all the elements that you need for the analysis. The data structure. Something that is very important to know about R is that R is a vector-based language. So everything starts with a vector in R. So when you understand this principle, everything gets very easy for you to try to, for example, in a way to try to generalize or to try to apply functions to elements in R, no, to objects. So R is a vector-based language. And the main structures of the vector are the vector itself, the matrix, which is basically a vector wrapped in a way that it looks like a mathematical matrix. We have lists, which is basically an object that you can put a lot of vectors inside, even another list. and it's something that is very useful if you want to bring a lot of objects to one analysis. If you want to only object, but you have inside it a lot of vectors. And data frame is basically a kind of a list, but in this kind of list it looks more like a table, and this is the most common object in R when you use for data analysis. So a single vector is a special case of a numeric vector. So for example, a single number is a special case of a numeric vector. So for example, if I put just a number 1 in R, and it will return to me the same number 1, and this number is a vector of length 1 because it's just one element, and this is like the length of the vector. And vector greater than this, like with more elements inside, are created using the function C. This is the base function in R, C, which concatenates information from different elements and put all together in one vector. So for example, in this example here, I have one vector which is with elements of integers. So we have 1, 2, 3, and they are placed all together like this. And there are some types of the most common types of vectors are the integers, which is basically this one with numbers, or numeric in the case when you use floating numbers, or decimals. We have the character, or also some more common in programming language, the strings. So we have the strings here, like let's say, for example, name of colors. So we have red, yellow, green, and also there is one other kind that's called factor and also logical. I will go further for the factor, so the logical. So logical is vectors with basically values of true and false, and this is just to basically we use these kind of vectors to test things, or to filter to get data from a bigger data set. So then we want to filter the data or subset it. So basically this is the way that the logical vectors are used. And the elements of a vector are separated to each other by a comma. So for example, I said that this is used concatenated, and then we have the number 1, and then we put the comma, and then we have number 4, and then a comma, and then number 8. The space between the commas is ignored by R. So it doesn't matter if you have it together or not together, but if you don't use the comma, it will be, instead of 148, will be 148. So this is will be a number. And remember that we use the function C, and all the functions are wrapped with the brackets. So we have parentheses. So we have C, parentheses, the values that we want to put inside, and then another parenthesis to close the function. So numbers are native to R. If you put a number in R will understand it as a number, as a value that it's like something that it's native to the language. But if you want to use other things, or also the logical vectors, like for example, true, false are also native to R. And if you can see also the difference here. Like this one has the color blue, and this one has the color red, and also this one has the color blue. So this is like for you to see that you are using a native element from R, and also to see that you are using a string or something that is not recognized as a native. It's placed in red. So since our numbers and logical vectors are native to R, you don't need to quote the values when you put it in a vector. So you don't use to use the quotation mark. But when you do it for other elements, as I said before, strings, which is characters or something else that you want to add to the vector, you need to wrap each element in the vector with upper comma on the quotation marks. So in that case, for example, we see here this vector has 5 elements. 1, 2, 3, 4, 5. And the elements that are strings, the elements that are not native to R, we wrapped it with a quotation mark. So we have apple, and between apple we quote with it with the upper commas, and then we use the comma, as I said before, the comma to separate elements. And then we have banana also quoted with quotation mark, and then we have orange also quoted, but number 1 and 2 doesn't need to be quoted because they are already recognized by the R environment. From this section and on, I will go to the show and tell. So remember, this is my folder, my main folder for the tricot analysis project oriented data, and then I will open this, clicking on the R project, and this is going to show me the R project for this course. Then I will click here, and then I have the 4 panels, and if I look at the data here, you can see some things. For example, you can see the data in the main folder. This is the main folder, and you can see that the environment is clean. There is no any other thing here. We can see the name of the project, tricot analysis, and here we see the directory that it is working. If you look at here, it is working on this path. R code, this file, and then I have this file. So the R project already set up for you the environment, so you don't need to change places and look for files outside this folder because everything is there. And here I'm going to open script, and then I'm going to go to section 3. So this is what I was showing before. So for example, if I have this number 1, 2, 3, I can type it here. We'll put it C, 1, 2, and 3. And to run an R code, I have to put control. I can click here and run, and I will run just this piece of code. And you see that it prints to me, in the language of R, it said prints when the output comes from what you asked it to do. So it prints for me the vector, which is 1, 2, 3. But I can also run it with a Control Enter. So if I press Control Enter in the line, it will run for me the code. And here's the same thing. So red, yellow, and green, and I can just run it and it will print for me red, yellow, and green. And remember what I said about the quotation mark. So if I put here red, yellow, and green, this will not recognize because it says red is not found. So this is different. So then I need to wrap it into quotation marks, so then it recognizes. And remember about the comma, when I said about the comma. So if I put here C 1, 2, 3, it will return for me one single element in the vector, which is the number 123. So if I want to create a vector with 1, 2, and 3, I have to put it as with commas between the elements. So here I also have the logical vector, which is a true, false, and true, false, true. So it's just these two. It's a binary or a dummy value, which is true and false. It's just this. And also, just to let you know that true and false can be what we call coerced. In R, this is the term that is used. We can coerce this vector into integer. So when you do this, we can do as integer, which is a function from inside R, and we put the vector inside, and instead of returning true, false, true, it will return to me the value 1, 0, 1, which sometimes can be useful when you say we are going to use this in the upcoming sections. Another thing that I almost forgot to tell you is that when we don't want R to run the code, or if you want to comment the code, like if you want to explain what you are doing, we comment. The proper way to say it is we comment with hashtag. So everything that comes after a hashtag in a R line of code. Now here we see the lines of codes, so it starts from line 1. Now we are in line 34. So every time we want to block a line of code, or if you want to comment a line of code, we put a hashtag, and everything that comes after the hashtag is ignored by R. So for example, I can put everything here, something, and this will be just like ignored. You see, R just jumped from these chunks of codes of text to this code, because this is the recognized line that is need to be run, because it's not blocked. And I can also block it with a hashtag. So this is very important. And going back to what I was saying before about true and false in these aspects, it's important to know that R is a case-sensitive language. So, for example, if I put true is different than true, which is also different than true, and it's also different than, for example, true, like this. So they are 4 different things, and they are very different in the terms of the way you apply it. So, for example, also if you want to call a function, for example, in this case, C is with letter K, lowercase, and if I call it like C, it will not recognize it, or is something else. C is another thing in R. So it's very different. And also it's very important because, for example, if you write in this case here apple with uppercase in the A, it's very different than apple with lowercase. So this is very important, because when we are trying to look for data or for information, and you are trying to match one data set with the other, and you find problems, sometimes it's just because you have one side you have uppercase things, and the other one you have lower cases. So it's very important to pay attention to it, so that R is a case sensitive language. And if you want to know more about it, you just need to look for it in Google or in other platforms. For example, what is a case sensitive language? And another thing that is important to know in R is about missing data. Missing data is also something that is native to R, and then when you have one vector that has a missing data inside it, this element is represented with this letter NA in uppercase, both in uppercase, like this. And this is very important, because sometimes, for example, when we are using data sets from Tricot, for example, some farmers or some participants did not reply to some questions. So in R, this will be considered like a NA. And sometimes we need to get rid of this information, because it can create some noise, or it can affect the routines of some functions. So sometimes we need to get rid of these kind of things to prevent R to produce errors. So here, for example, we have this vector which is length 5 with an NA inside. And so, for example, now I will go back to the previous version, which is length 4. So in this case, for example, I can check the length of the vector with this function called length. And if I run this code, it will return to me the value 4, which is the length of this vector, how many elements I have inside it. So it sees that even if the NA means not available, R considers this as a valid element inside the vector. So it returns to me the value of 4. But if I check this one, for example, the value will be 3 because I don't have NA. So this is important to know because, as I said, sometimes you need to get rid of NAs. And one way to find NAs in a vector, because of course here we have 4 elements and we can easily find the NA visually. We're just looking at it, we can see it. But if you have a vector with 1,000 elements inside, it's very difficult to look for each of these elements in the big vector. So one way to do it is using this function called is.na. So in this case, for example, I have this function called is.na with parentheses, and inside I will put the vector with the NA. And then if I run it, it will return to me a vector with false, 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 true. So false, 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 true. So this means that this one is not NA, this one is not NA, this one is not NA, and this one is truly NA. So this is what it means. It's a vector with false and trues. But imagine that we are not looking for the NAs. We are not available data. We are looking at the ones that are actually available. These 3, for example, apple, banana, and orange. We can use the same function called isNa, but to get the vector in the opposite direction or in the opposite way, we just need to put the exclamation in front of it. So with this exclamation, which is also a kind of function in R to represent a negation, like denying or negging this. So I can put this, and then I can see a different vector, which in this case will return true, 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 false. So it will return for me which one of these elements in this vector are valid, are available, and which of the elements are not available as a false thing. So here is the basics of vectors. Now this is where we learn about vectors and everything of we need on the basics. If you want to stop here for a break, you can do it, because then we are going to talk about lists. Well, lists are another kind of data structures in R, and basically lists as a compilation or a big compilation of all of a lot of vectors. And then the advantage of using a list is that in the list you can put vectors of different lengths. Remember that I was talking about lengths in a vector, no? So length is the representation of how many object or elements we have inside this vector. In the case of this vector, for example, here we have 3 elements, so the length is 3. And in this case we have 4 elements, the length is 4. So this is basically the length. And then lists are a kind of data structure that allows you to put the vectors of different sizes inside it, and then you can use it for other analysis in the process. So here we have an example of a list. For example, this one, lists are called with this function called list, and also remember to put it in parentheses. So we have this function list, and inside this list we can put vectors, no? So let's say that we want to put a vector of length of vectors of numbers. So let's put 1, 4, 6, 7, 10, and 11. So then we have a list where we concatenate the value, so it applies the same logic of the vector, and also then inside the list we put a vector, and this vector is concatenated with C, parentheses. And if you want to add a new element to this vector, you can just put a comma after the parentheses for the concatenation of the first vector. And you, for best practices in visualization of the code, we press enter for a new line of code, and then we can put another vector with also C, and let's say that's a vector with letters. So letter A, letter G, letter R, J, and also an NA. Let's say this is a NA here. So this one has a length of 1, 2, 3, 4, 5. And this one has a length of 1, 2, 3, 4, 5, 6. So they have different lengths. And also I can put just one object, which will be a vector, as I said, a vector of length 1. So let's put it as a logical one. So let's say false. And remember that here I put comma and here I put comma. But now that I'm closing the list, I don't need any other elements. I don't need to put comma here, because if I put a comma here, R will expect a new vector after this comma. So since I'm not using any more vectors, I'm just putting 3 vectors inside it. I will put it here, and if I press enter, it will return to me a list. So you can see 3 elements in this list, 3 vectors, and each vector with different lengths, but they are a single object in R. So if you see, for example, that the first vector in the list has the name 1, so we have 1, and then we have 2, and then we have 3. Okay. Later, before I can explain to you, for example, the difference between this number 1 with two brackets and this one with 1 bracket. They are quite different, and generally when we have elements with 2 brackets, it's because we are working with a list. So basically this is what we need to do to know about lists. Lists are quite simple elements because of the logic on the vectors. Now it is important for you to understand all the logic behind creating a vector in R, and then everything will get very less complicated. And then we can go to another type of structure in R, which is a data frame. Data frame is simply a vector or a list with vectors of the same size. So the difference between the list and the data frame is that the list, you can put everything in the same size. You can even put a list inside another list. But in data frames you don't do this. You need vectors with the same length, so you can create a data frame. And a data frame has a structure or visualization that's quite similar to a table in like an Excel table. Let's go, for example, on this example of the iris data, which is a very common data set in R for examples and using as the toy object. So you can see iris. If you just type iris R, we will understand it, because iris is an object inside which is hidden in R. You don't see it here in the environment, but it's inside R because it's a native data frame from R. So if you type iris and press run, it will show to you a data frame like this, no? So we have the iris data from R, and then I can check, for example, with this function str, the structure of this data. So it will return to me something like this, and this $sign is something that is also observable in lists. So this is the one way that you know that this the data frame is a kind of list as well, because we have this something called data frame, and it says to us that we have 150 observations, which is 150 rows, and we have 5 variables, which is 5 columns in the data frame. And the first one is this name sepal length, which is a number. So we have values like floating numbers. We have the other one is sepal width, petal, and another one is petal as well. And we have species, no, like which is the name of the species of this element, this observation. No? We have a is a factor with 3 levels. In the slides that I provide in this lecture, there is a link for you to access the information on the factors. So what is actually a factor? You can see here on the link. So this is from the book of R for Data Science for Hadley Wickham. So this is he explains a bit on what is a factor and what is the importance of using factors. This information is on this slide of this lecture. So this is the data iris, and also I can check for the dimensions. Like another function called tim. So if I put iris, and it will return for me 150 and 5. So it returned to me a vector with 2 elements, and the first element of this vector is the number of rows, and the second element in this vector is the number of columns. There is another function for data frames as well, which is called nCall, and this returns to me a vector of length 1, which will be the number of columns, 5. The other one is nRow, iris, and it will return to me the number of rows in this data set. This is a very useful tool because sometimes we just need to know the number of observations, the number of which is sometimes is equivalent to the number of participants in a trial. So if you want to keep this value for future reference, you just need to use this function, and I will let you know in the coming minutes how this can be saved in the R, as an R object. And to create a data frame is very simple. Now you just need to use the function data dot frame, and then you wrap it as a with brackets with a parenthesis, and then in the data frame you put the name of the variable. So for example, let's say that this variable will be name, farmer name, and then I will put equal, which is the value to assign the vector. So then I will put C, and then I will put the number of the farmers. I will just put some letters to not feel like something like this. And then I will put here age, for example. This is, remember, I used this. I used the farmer name equal C to concatenate the vector in one element. Since these names are not native to R, I use the the quotation marks to wrap them in separated in this vector. And then I will put age, for example, which is another vector for the farmer age. So let's put 23, 34, and 50. Remember that numbers are native to R, so I don't need to keep it for with rapid values, like quotation marks. And then I will create another one, which is called, for example, participated. Let's mean that this means that the farmer participated in the trial. So let's say that this one participated, true, this one didn't, and this one did. So then we have a data frame for this data set that we are going to create, like a farmer name, age, and participated. I will put more information here because we can use this data frame for future reference in the upcoming moments on this lecture. So let's say here I will put another name here. And I will put 40 and 34 and 36, and this one true. So now I have a vector with 5 elements, 5 rows and 3 columns, a data frame. So now I'm going to talk to you about R objects. What is the matter of R objects? If you see on this so far, in this almost 100 lines of code, what we did so far is just playing with the values. We're just putting values here and running, but you see that the environment is still empty. This means that everything that we did here so far is not retained in the R environment. So this is, you cannot use for future reference or for future use in the script, in the other upcoming rows of the script. So to assign objects or create objects that can be stored during the analysis of the data in the R environment, we need to assign them and create a name for it. So to do it, what we do to assign values or to assign objects to R is using these elements here, which is I call it an arrow to the left, or you can use this sign of equal. Particularly, I don't like to use equal because equal also can be used inside functions, and we are going to get into that in the future. I will not explain now, but if equals can also be used inside functions. So it creates like a bit of confusion sometimes. So I would rather use the arrow to the left to assign objects. So let's say that we want to assign this object and use it for future reference. So this is I will copy and I will call it DT for data frame, and I just need to copy it here and I run it, and now I have DT, you see. And if I click here, I see basically like a table. It's the farmer name, age, and participated, if the farmer participated or not in the trial. And then this is an object that is created by R. And if, for example, I use this function called ls, and I don't need to write anything inside, I just need to run it, it will show to me that in my R environment, I have something called DT, which is this one that I created some seconds ago. Another way to assign to create a data frame is to assign. First, you create the vectors like this. In this case, X, Y, Z, and W, and then you do like this: X, Y, Z, and W. And if you see that here we have 4 vectors. And all the 4 vectors go from 1 to 3, 1 to 3, 1 to 3, 1 to 3. And then I just need to use the function data frame, and I just need to put X, Y, Z, and W, and I will call it my df, my data frame. And I also have another data frame called my df, which is an object with 3 rows and 4 columns. So this is another way to assign objects. And imagine that I will delete it, and I will go back to the previous one that I already have, which is called DT. And I don't want these ones here to messing around my environment. So I can remove them. I can just take my df with the function rm, w, z, y, in X, and I can remove it from the environment with this function called rm. So let's say that I want I have this data frame and I want to add a new column to it. Now I have the data frame that has 3 variables, 3 columns, and I want to add a new column, which is called, for example, farm size, which let's say that is in hectares. So I have one vector that is 0.5, 0.3, 0.5, 0.2, 1.2. The other one is 0.6, for example, and this one is 2. Let's say that this farmer is a big one. So we create this vector, and I want to put it inside the data frame. So I use this function called cbind. So I do dt cbind dt farm size, and now I have one function called another data frame called with the information of farm size. But remember that I didn't assign it to any other element. Now, even if the dt already exists and farm size already exists, I don't assign it to any name. So let's say that I will keep the same name dt, and I will put arrow to the left, and this is the dt. Now dt has farmer name, age, participated, and farm size. Now we have covered all the aspects on the data structure, and the next elements that we are going to cover, the next topics that we are going to cover in this lecture, is about indexing of data. Now, how can we access data inside the data frame, which is very important for the next analysis, and about R packages. So if you want to take a break here, feel free to do it, and then next we are going to talk about indexing. But before going to talk about indexing, I have some tips on how you can name objects in R and some best practices on doing this. This is also available on the slides of this course, and I have this section called some tips in creating objects and assigning values. So to try to be objective when you name your objects, that try to be very clear on the name. Don't make a very large name, like a very large name that makes you complicate to write it. Remember that if you want to use this object, you are going to write it again on the script. No? So remember that don't write a very large name that is going to get trouble for you in writing this and so on. Also, you don't have to use a space. The name should be everything put together. And if you want to create something that is clear for you with spaces, you should use, for example, underscore. I said I don't recommend you to separate names like with dots, because dot is something that is useful for methods, mostly the S3 method, which is a very advanced topic, and I don't want to talk about this in this lecture. But for those that are curious about this method, it's just need to click on this link. But so the good name, in my point of view, is either a name that doesn't have this, or the name that is separated with underscore instead of points. And also try to avoid certain names when you use for naming objects. For example, name C, T, df, matrix, data, or on any as you learn more R, you're going to get more of these names, and you're going to know why you don't need to use it, because you don't have to use it, because these names are functions in R. So if you, for example, if you write an object and you call it C, you are overwriting the function in R, which is C, with the one that we are using a lot so far, and you are overwriting it with something else. So this can create problems for you in the other in the further levels of the script. So instead of it, try to create more like something more generalized or more related to you, like my matrix, my data, my list, or something like this, avoiding these names. No. And then we can go to indexing. Indexing is a way to access the elements in an R object using its position in the vector. So remember that we are working with vectors, and everything in R is thinking about a vector no? So it's a vector-based language. So all the indices in R, all the vectors in R now, it starts with the number 1, and then it goes until the end of the vector. So if you have one vector of length 5, so the index for the vector will start with 1, 2, 3, 4, 5 until the length of the vector. So for example, in this case, I have this vector, and I will go to the R environment again to the show and tell part. So for example, here I have this vector called x, let's say x, and then I have 1, 2, 3, 4, 5, 6, 7, 8. No, this is x, and the length of x is 8. So then let's say that I want to access the value that is stored in the first position of the vector. So what I do is pick x. This is the vector, and if I print it, it will return to me the vector with the 8 elements. But if I just want the vector that is the element that is in the first position of the vector, what I do is put the number x, and then I use brackets, and then I put 1. But remember, this one that I put here does not represent this one here. This one here represents the index, the position of the first element in the vector. So let's say 1, and it will return to me 1 because this one is the first one. So maybe this was not a good example. I will put here, for example, number 4, and I have the same vector, and this vector is x. So then I have 4, 5, 2, minus 1, 11, 15, 6, and 3. So if I put x brackets 1, I want the first element in the vector x. So this will be number 4. If you see here, number 4. And I want now, for example, I want to take from the first until the third. So what I can do is just put 1, 2 dots, 3. So then R, we will understand that I want from 2 dots. It's a way to represent from, not from 2, like from 1 to 3. So then I have 1. I will get the vectors, the elements in the vector that represents the position 1, 2, and 3. So these are the values 4, 5, and 6 in the vector, or 4, 5, and 2. So let's imagine that now I want the elements from position 3 and position 5. 3 and 5, not 3 to 5, but 3 and 5. So then there is different from this one here. I need to put here, and I put the brackets as well. But instead of putting 1 and 2 points or 2, 5, for example, 3 and 5, remember that when I put this, I have to wrap it as a vector. So this is another vector inside the vector. So when I do this, I'm saying to R that I want from the vector x, I want the elements that are in the position 3 and 5. So this will return to me numbers 2 and numbers 11, which is the 3 and 5. And let's say that I want 3, 5, and 8. So this will return to me 2, 11, and 3. So this is the basic lessons for indexing. And there are any other lessons, for example, when we use this this function called in. So this is basically to check if some element is, depending on the way that you position the in, it can be an element. If you check if the element is inside X, or whether X has the value that you want to check. So for example, I don't expect you to understand this one. I will just show the example here, but this one it's a bit more advanced in this lecture. So for example, let's say I want to test 3 in X. So I want to check if 3 is inside X. So if I do this here, it will return to me a value true. So this means that inside the vector X, I have one element that is 3. So this is very important when you are looking for someone. For example, I'm looking for a farmer name or some region name or some district or something. I can just put here and try to find it. Another way is to check if the X has where in the X we have the number 3. So in this case we do like X in 3, and then it will return to me a vector of length 8 with the values false and true, and the true represents when the 3 is available here, for example. And there are other functions called match and also which is more also advanced. And I would just, for example, here I want to match the one that is number 5, and it will return to me position number 2 is where the number 5 is in the vector, and which elements here in this vector is larger than 3. For example, if I want to know, for example, the value, which one is larger than 3, I put here and it will return to me the values with the indexes. Now that 1, 2, 5, 6 and 7. So 1, 2, 5, 6 and 7 are larger than 3. So this is the way for using. This is a function called match, and this one called which is quite self-explaining, I guess. And another way is indexing the data frame. So let's go back to our data frame, which is the DT. So if, for example, if I want to take all the elements from the first column in the DT, I put it like this, and then I will get farmer name. Now you see DT brackets 1, so then I will get the farmer name, because this is the index for farmer name in R, number 1, this object, number 1. And another way to take is, remember that I said before, that the data frame has 2 dimensions. So the first dimension, let's put it like this. The first dimension is the row, and the second dimension is the column. So the first one is the column, the second is the dimension. So this is the way that it's seen in R. So for example, let's say that I want all the elements of the row 1 in this vector. So DT row 1, and then it will return to me the values that represents the row 1 in this data frame. So this one is the farmer name, age that participated, and the farm size for farmer 1. And here, for example, take the elements from row 1 to 3 and columns 3 to 4. So this is applying a bit more deep on this what we did here, but this goes a bit more deep because we are working with an object with 2 dimensions. So now let's say that we want the elements from row 1 and 3 and columns 3 and 4. How can we do this? We put the name of the data frame, brackets, and then rows 1 and 3. So remember that the 2 dimensions. Now the first is the row and the second is the column. So rows 1 and 3, and then I have to put C 1 and 3, and then columns 3 and 4, columns C and 3 and 4. So this will return to me this object, which shows that if the farmer participated or not, and the farm size for farmers for the observation in line 1 and 3. And if I want to access the column named for example farmer name in DT, I can do this, for example DT, and I put quotation mark farmer name, and it will return to me the farmer name. When I use the $sign which is this another native element from R, when I use it, I can access the element and get, instead of getting the data frame, you see that here it printed for me a data frame, which is with one column. But if I want to do, if I want to get the vector of it, I'm going to get away of the data frame, I just need DT farmer name, and it will return to me a vector. You see that the printing method is different. Now here it printed in the long way, like from up to above, and when it's a vector it prints like this. So this is one way that you can check how this works. And for example here, let's say that I want lines line 1 and 2, and I want a farmer name and farm size farmer name, and then I have these two. So these are the ways to index values in R. There's many other ways, and we are going to do in more deep in the upcoming sections, because I think that it's better also to work this in the practical way. So I recommend you to train it and to do the exercise for it, and train if you are not very used familiar with R. I recommend you to train it as many times as possible, because this is something that is very important for you to learn for the upcoming sections. And then the last part is related to R packages, and then I will go back to the slides. So R packages. What's an R package? R package, as I said in the previous moments, is a collection of R functions, compiled code, and sample data. So if you see that you have a function, a script that is very useful for others, and you can generalize this, and you can wrap it as a function, and then if you prefer, you can write it as a package. So it's basically like a package with a lot of routines to analyzing some or processing some kind of data, and then it return to you what you expect from this. The most common way to, like most of the day-to-day work will require you to have at least one package outside the base package in R. And the most common way to access the R packages is on CRAN. CRAN is the Comprehensive R Archive Network, which is the where you find all the packages that are available. Currently, I think there is about 18,000 packages available in R. And one simple way to install it is just using the function install packages, and then I wrap the name in in quotation marks, and then I put the name of the package. Remember that it's very important that R is a case-sensitive language. So if you have packages with uppercase and lowercase, sometimes the developers play a bit with these letters. So it's important that you follow exactly this. This is a good example is the cleanup-tools package. Cleanup-tools has upper and lowercase in different. It's across the name of the package. So it's very important to follow this name. Otherwise, the R will say that the package does not exist. And sometimes the packages, when we see that the packages are still under development, or for example, if you want to access the latest versions of the package that are still not available on CRAN because for some reason the developer thinks that the package is not stable enough to go to CRAN, and then the developer just want to keep this packaging on like for developing for alpha testing or beta testing. So generally these packages are stored in the developer web page, and the most common way to storage packages is on GitHub. GitHub is a platform for software development, and most of the ARP codes ARP packages nowadays are stored on GitHub. So one good example is the package GoSet, which I still did not submit it to Chrome because it still requires a little of the fine tuning on the documentation. So one way to install this package is first using install package for the package remotes, and then the package remotes has a function called install _ GitHub, and in this you can install packages from GitHub into R. There are two things here. The first thing is the name of the user, and also in this case is the Agri Data Science. So this is the name of the user that has the package, and then you put / the name of the package. So this is one way to download it. And every time that you load a package, or if you run an ARP package, you just need to install it once. So every time that you update your ARP version, you just need to install the package, but you don't need to do it every time that you are going to use R. You just need to do it once. But the library or loading the package is something that you have to do every time that you open an R section. So to do it, you just need to run this command that's called library. So for example, here I'm calling the package ggplot. And it's okay if you use, for example, ggplot with quotation marks, or if you use without quotation marks. It R understands in the similar way. But the best practice for you is that you use quotation mark. And if you want to know more about it, like why you have to use quotation marks or why is recommended, I recommend you to read this document here in the link. And finally, I will talk about error and warning messages. If you are a new user, it's very common that you get afraid and you see an error message, or if you get a warning, or if the code doesn't work really well. So my recommendation is that you don't be afraid and you relax a bit, because most of the errors and warnings are someone in the web already solved it, and you just need to find a way to get the answer for this problem. So for example, error messages occur when you try to run a function, but you provide in some way the wrong inputs. By consequence, the object that we try to create is not generated by R. So for example, here, remember that the function cbind, and remember that data frame should have the same number of rows, the same length. So in this example here, I'm trying to put together two data frames. The one is iris and the other one is air quality. And what R tells me is that R returns me this error saying here, error in data frame, 3 dots, argument imply different number of rows. So the iris data has 150 and the air quality data has 153. So this means that R cannot combine this with cbind because they have different dimensions, and returns the error. And you cannot produce the outputs. Another thing is a warning message. A warning message when you run the code and the code works well, so you get the output that you asked for. But for many reasons, depending on the function, R will return to you a warning saying, look, something happened here when we are trying to do this, what you asked for, and just paying attention to it. So in this case, for example, is that I'm having I'm binding, I'm combining two vectors to create a matrix, and I have one vector that has length 4. And the other one has a length 6. So I have 1 to 4 and 5 to 10. So I have two vectors with different lengths. So what R does is it executes the function anyway, so it's there, so it creates the combination of vectors that I want to, but when it creates it replaces or it replicates the two values that are missing in the first vector. It replicates using the two firsts of the vector. So let's say here we have 1 to 4, and also it's a vector that goes from 1 to 4. So 1, 2, 3, 4, and since this is a vector of length 4 and this one is a length 6, what R does is creating copying the first two elements, so to fill the space that we have in the first vector. So here we create like 1 and 2, and this one is the vector that I asked for, no, the 5 to 10. So this is to tell you that this was done. The matrix that you asked for is ready, but R did this in some way that can affect the analysis that you are going to perform in the future. So if you see a warning message, pay attention to it and try to find why this message is coming out. But sometimes there are some warning messages that you can ignore, but to ignore it safely, you need to understand what the message represents. Tips to deal with errors and warnings. So the first one is error and warnings are I know that they are very difficult for native languages of R, because they are very common programming jargons. No, very difficult to understand when you don't have the background on programming. But don't be afraid. Most of them are already reported on the web. So if the R community is very friendly and responsive. So if you have any question, you just need to find help somewhere. I have some tips here. First, don't panic and read carefully the error message. And then you can copy the error. So let's say if you get this error message, for example, you just need to copy this message and put it on Google, for example, and it's very likely that you're going to find someone that already reported this error, and you can find the answer for it. This web page called Stack Overflow is a most common platform for solving errors in R or other languages. So if you can, it's very likely that you're going to find the answer for your error there. Sometimes also in Twitter, on Twitter you can also use the hashtag #RStats and you can find help for it. And I would say lastly, like this will be your call for help, like the last option that you have. Don't do this as first one. I recommend you do this as the last call for help, is that you contact directly the package developer. I say this because imagine that you have a package. I am a package developer, and if imagine that you have 100 people, and out of these you have 20 that are asking for help or for some error. That is sometimes easy to find on web why the error is happening. So imagine that you are going to get this, and then you have to reply to things that are already on web. So sometimes it takes from your time, and it's I would say that's better if you do it as last option. And one way to do is to go to the package website, and in this field called bug reports, you're going to find the vein, or the way that the developer told to avoid to report the errors and get help. If you don't have no idea what you are doing, I was there before. So I started in R and didn't understand what I was doing also. So don't be afraid. If you have any question, call for help, and then the R community is very helpful and very, very welcoming. So if you don't be worried, like go ahead and try and test, and don't give up of R. It's the learning curve is very steep, but by the end you are going to get a lot of it. For further reading, which I recommend for this course, is taking the R Basics from Professor Norman Matloff from UC Davis. He has prepared this thing called Faster, which is a way to you for learning R for people without any background in coding. So the link for this is here. And if you go a little more advanced in R, you just need to check, for example, the second version of Advanced R from Hadley Wickham, and great insights there. Also the ebook Introduction to Data Science from Rafael Irizarry. And also RStudio has a lot of webinars showing how to do things in R, and there is a lot of things to learn. Thank you a lot for watching this section. I hope that you learn about R. I hope that you test and you train a lot and do the tips, like go for the tips that I did on finding help. And in the next section we are going to talk about introduction of placket loose, which is a lecture given by Dr. Heather Turner. Thank you.